Okay, today we're going to be talking about SPC in M.O.L.E map software. So what is SPC? Statistical process control. And so what are we looking at when we're viewing SPC inside of map software? We're looking at a number of profiles, and SPC is generally done on one measure over multiple runs. Here in the spreadsheet we have a list of specific measures. These measures are all tied to an individual channel. In this case, they're all tied to channel 1 because to do SPC we need like type data. And so if we're looking at a specific temp or measurement like peak temperature, we want to make sure the temp is measured in the same spot each time and on the same channel. You can see we have check boxes on the top of these columns. These check boxes indicate we're going to create an X bar R chart for it on the SPC tab, which we can see here. We have various data that comes over with it from the spreadsheet. We have the individual measures for each of the data runs that are visible on the spreadsheet. They're plotted out for you here. This happens to be a X double bar, meaning an average of averages, and that's subgroup sizes too. The upper and lower control limits are being calculated automatically based on the data that is visible in the spreadsheet. And then we have a range chart below it. That's where the R comes from, and this is an average, so it's an R with a bar, meaning average. You can see we also give you the number of samples. In this case, n equals 5. We give you the minimum value that was in the set and the maximum value in the set. In this case, the X double bar, the average of averages, which is 3.8, and the standard deviation. Continuing here, we've calculated CP and CPK. You can see it's in pink, meaning it's invalid because statistically speaking, we don't calculate CP and CPK that has been averaged. We do calculate CP and CPK on an individual's chart, where we can select our subgroup size when we choose to have an individual's chart. It's in our preferences, and when we go to our file pull down and enter into our preferences, you can see the software intuitively knows we're in the SPC section, and it brings up the SPC tab of our preferences. Here you can see we can change our subgroup size, and we have the option to go between 1 and 6. And I'm going to choose 1 and hit apply. And you can see that several changes have taken place. Our control limits are no longer being calculated because control limits by definition need to be calculated with average data. And since we're not averaging those numbers anymore, our plot turns into a spec limits chart instead of a control limits chart. And we define those spec limits on our spreadsheet, which I'll show you in a moment. And they turn red, indicating as such. We give you an X single bar now. This is the average of all the data points. We still give you the number of samples, which has increased because we're not averaging the averages. We're on the single sample individuals chart, and now our CP and CPK have turned black, indicating they're mathematically valid at this point. So how do we add measurements to this list of plots we have? Well, we do that in our spreadsheet, and I'll show you how to add a calculation or change a calculation here. If we choose to, we can edit or add content, and then we put in the type of measurement that we want to do statistical analysis on. In this case, I may choose to do a slope value. I need to choose the channel in which I'm interested in taking that measurement from, and we want the like type data. And so I'm going to choose channel 2, Then I'm going to define what type of slope I want to measure. It could be maximum cooling slope, maximum rising slope, maybe maximum rising or cooling. I can define that between temperatures or certain parts of the profile, and I can decide how I want that to be calculated, whether I want an average or a linear progression, and over what time span that average should take place. So in this case, I'm going to do a cooling slope, maximum negative slope, and I can constrain it if I'd like. In this case, I'm not going to. I can choose some clever cell colors here to help understand what this is. Cooling slope, cool is blue, so I'm going to choose that as my cell color. And then to make it easier to read, I might choose a high contrast text color. And then I could put an upper and lower spec limit. Uh, this is what we use for calculating our CP and CPK. And so our upper specification, the larger of the two numbers, might be a cooling slope of 0 degrees per second, and our lower specification limit should not exceed -4 degrees per second, because -4 is lower than 0. And I'm going to calculate out to 1 decimal place. So it took the value for channel 2 maximum negative slope for all these runs in our working directory, and you can see that some of these exceeded my 4 degrees maximum cooling rate, and these are underlined in blue, meaning that they're below my lower spec limit. You can see my spec limits are pointed here at the are painted here at the bottom, and we can choose whether we show this or not, and that is in our preferences settings, which we've recorded in a separate video. It gives our minimum, our maximum, it gives our average and our standard deviation. What's important to understand about average and standard deviation is if we choose to, we can have the software choose a range for us or a specification limit based on the capability of our process. So we can say based on all the average of all the data runs that are available, in this case negative 4.167, apply a spec limit that's plus or minus 5% of that average, or 10% of that average. So plus or minus 10% of an average of -4 would be approximately plus or minus 0.4 degrees per second. If we choose to do standard deviation, 1, 2, or 3 standard deviations, plus or minus, you can see we've calculated out the standard deviation of our current set. It's 0.73. And so if we multiply that by 2 standard deviations, it would be 1.4 plus and 1.4 minus. So this is an easy way to apply a range or a range around a spec limit that you can use for SPC. Now, of course, if we choose standard deviations, it will affect the way our SPC chart will record. And to make this visible, we put a checkbox on it, and now it will show up at the bottom of our SPC chart. And so you can see that here. Maximum negative slope, again, we have a subgroup size of 1. That's an individual's chart. So this is a spec limit chart, and it shows we have several outliers that are outside of our spec limits. Because we have outliers outside of our spec limits, we have a negative CPK. And so that concludes our overview of SPC and MAP software.